Okay, number 33. Which of these is an isomer of this compound? Okay, well this compound has two F's, two H's. Okay, so this one we can knock off B because that's exactly the same compound, just flipped over. This one has too many F's. Okay, and this one is totally the wrong formula, so the answer is A. Two F's, two C's, two H's. Okay, which is the correct name for this compound? Three of them, that makes it propane, so we can knock off the butane one. It's got two bromines hooked onto carbon number 1, 1, 2, 3. So it's 1,1-dibromo-propane. Okay, which functional group can be found in this? This is C double bond O. It's either an aldehyde or a ketone. And since it's between other carbons, then it's a ketone. Okay, the structure of which compound is given below. Okay, it's O8, so that's an alcohol, so we can knock off nail polish remover and vinegar. And it's two carbons, so it must be grain alcohol, ethanol. Eth means 2, propanol would be 3. When the equation for the combustion of propene is balanced, okay, so we're talking C3H6 plus O2 turns into 3 CO2s and 3 H2Os. And we can see what's going to happen. We're going to have 3 times 2, 6 oxygens, 3 times 1. So we're going to have 9 oxygens on this side. So on this side we're going to have 9 halves. We're going to have to go back and double everything. So that's going to give us answer B, 9 for the O2. Okay, an alcohol reacts with a carboxylic acid. Then we are talking about an ester. Ester in water. In a sample of salt water, the salt is the solute. The salt water would be the solution, the water would be the solvent, and precipitate would just another answer. Which of the following is expected to be soluble? Okay, soluble. So sulfates are soluble except for CBS, calcium, barium, strontium. Sulfides are hardly ever soluble. Chloride, bromides, and iodides are usually soluble except for silver, lead, and mercurous. So it's going to be answer D, strontium bromide, and you're just going to have to use the solubility rules given on the test. 41, how many grams of sodium hydroxide pellets are needed to prepare this? Okay, well this is kind of a big problem. So molarity is number of moles over the volume. Okay, and we're trying to find how many grams, so we're going to have to find the moles. So moles is going to be molarity times the volume, and molarity is the 0.15 molar, and the volume is 50 milliliters, which we're going to change to 0.050 liters, and that's going to come out to be 0.0075 moles. We're going to take that number and multiply by the molar mass, 40. So when we get 40 grams per mole times 0.0075 moles, then we're going to end up with an answer of 0.3. So the answer is A. 42. 50 milliliters of a 200 milliliter sample of 0.1 molar sodium chloride solution is spilled. What is the concentration of the remaining solution? If you spill some solution, what's left over is still the same concentration, so we're still looking for 0.1, answer C. And this is the problem for people who don't read carefully. They just look at the numbers and say, oh, that's a dilution problem, let's just throw it in the formula and go on. But you need to look at it very carefully. 43, list these in the same slide in order of increasing concentration. So we want the least concentrated to the most concentrated. Well, we can see if we had 60 grams in 120, the smaller volume, that's going to be the most concentrated. So we need answer 3 is going to be the last answer. And of these other two, 30 grams in 240 or 30 grams in 120 milliliters. Okay, so we can see that the least concentrated is going to be the first one. So it's going to be 1 is less concentrated than 2, is less concentrated than 3. Answer A. 44. A 100 milliliter sample of a solution with a concentration of 5 molar is diluted to a new volume of 400. Okay, so this is a dilution problem. So this is volume times molarity equals volume times molarity. Okay, the volume, we have 100 milliliters of 5 molar is equal to 400 milliliters times x. So to solve for x, x equals 100 times 5 divided by 400. And that's going to be 100 over 400, 1/4 of 5, 1/4 of 5, 1.25 molar. Okay, property of acids, they are sour. Okay, nothing neutralizes water. Slippery and caustic, those are bases. Okay, the dissociation of calcium iodide, dissociation means break it up into its ions, and so we would get a calcium ion and 2 iodide ions. Okay, a solution that conducts very well, okay, that is a strong electrolyte, just the definition of strong electrolyte. Okay, which chemical is the conjugate base? Well, NH3 turning into NH4 plus, that is picking up a proton, so that's a base, so this must be the conjugate acid. So this must be the acid, and this is the conjugate base. So we're looking for OH minus. Okay, a solution has OH minus of 10 to the minus 3, so its POH is 3, and the pH would be 14 minus 3, so that would be 11. Okay, what is the OH minus concentration in which the H plus is 1 times 10 to the minus 6? So we want to do 1 times 10 to the negative 14 divided by 1 times 10 to the negative 6, and that would be 1 times 10 to the negative 8. Okay, cabbage juice turns green, that's a base, and which of the following could be its pH? So basic pH must be greater than 7, so that's neutral, that's acidic, has to be 10. Okay, solution to cabbage juice is blue, that's base, and slightly lights up, so that means it's weak. So we're looking for a weak base, answer D. Okay, who is a single replacement reaction? We need a compound and an element. Turns into a compound and an element. The B, that would be synthesis, C would be double replacement, and D would be decomposition. Okay, when the equation above here is balanced, okay, we have 3 O's and 4 O's. We're going to balance those first. So we'll put a 4 there and a 3 there. And then we can see we just need 1 pH3. So the answer is going to be 3. Because we're asking about H3PO4. When solutions of potassium sulfate, calcium bromide are combined, what are we going to get? We're going to get potassium bromide, that's K plus and Br minus, and we're going to get calcium sulfate, CaSO4, and by our solubility rule, sulfates are usually soluble except for CBS, calcium, barium, and strontium, so the answer is C, that is a precipitate. Okay, what do we have? Magnesium metal reacting with hydrochloric acid. Okay, that's going to be a single replacement reaction. We're going to get magnesium chloride, MgCl2, and hydrogen gas, which is H2. So there's answer D. It is not answer A. Hydrogen's the right idea, but it comes diatomic. We're not going to get ions. We're not going to get magnesium. Okay, this zinc, what's happening to the zinc? Okay, it is losing electrons. And remember that Leo the lion says Gur. So losing electrons is oxidation. So it's not gaining electrons, and it is oxidation. So it's answer B. 58. If we react silver nitrate, potassium chromate to form silver chromate and potassium nitrate, who's oxidized? Nothing is oxidized because nobody is changing their charge. They're just shifting, partners. So it's Ag plus on both sides, it's K plus, and here nobody's changing charge, so it's not redox. During the ornament lab, hydrogen gas was produced according to this equation. Which element is oxidized? Okay, we need somebody whose charge is going upwards, and that's the zinc. So Zn going from neutral to 2 plus by losing 2 electrons. So it's the zinc metal is being oxidized. Now 60, what mass of sulfur dioxide is produced when 245 grams of sulfuric acid reacts? Okay, this is going to be kind of a longish equation, so it'll give me a moment to just write it out. So we start off with our grams of H2SO4, use the molar mass to go from grams to moles, use the numbers in the balanced equation, 2 and 1, so 2 moles of H2SO4 gives us 1 mole of SO2, and use the molar mass of the SO2, 64 grams per mole, and when we get all done, that comes out to be 80. Answer B. And that is the last few questions.